Dear student, we are discussing about the isomerism in coordination compounds. In this isomerism in coordination compounds, in the last video we have discussed about the geometrical stereoisomers, in which stereoisomers they are classified as geometrical isomers and optical isomers. In the last video we have discussed about the geometrical isomers, in which we have discussed about the cis and trans isomers. Now in this video we are discussing about the optical isomers. Now first we shall see about the optical isomer, definition of a optical isomers. These optical isomers are also called as enantiomers. Now, what is the definition of optical isomers? The complex or molecular ion that are non-superimposable mirror images of each other are enantiomers. Means you can say the complex or a molecule or a ion which have mirror images. Mirror images means that is the exact images, or non-superimposable, you can say, that have non-superimposable mirror images. What is the optical isomers? Optical isomers are the complexes or molecule or ion which have non-superimposable mirror images. Means they have the exact mirror images. Such molecules are termed as optical isomers. Now, non-superimposable mirror images are the chiral. What is chiral? We shall discuss in chapter 10 about the chirality, or you have seen about the chirality in chapter 10, so that is not the matter of discussion in this video. Now enantiomers have identical properties, differ in their response to plane polarized light. The enantiomers that rotate the PPL. What is PPL? That is a plane polarized light. Now, what is the property of an enantiomer? Such molecule have a special property, that is a rotation of a plane polarized light either at right hand side or left hand side. When such enantiomers that rotates the plane of PPL or a plane polarized light to right direction or a clockwise direction is called as dextroisomers. When these enantiomers rotate the plane polarized light into right direction, then such a isomers or a molecules are called as dextro. Dextro, which is in abbreviation written as small d. Dextroisomers. When such enantiomers rotate the plane polarized light to right hand side, then such isomers are called as dextroform or dextroisomers. While when they rotate the plane polarized light left hand side, then it is called as levo form, or you can say small l form, or levo isomers. So remember this. Now these are the properties of the optical isomers. Now, or enantiomers you can say. Now we shall see some example in which a molecule have their mirror images or a non-superimposable mirror images of each other. So first we shall discuss about the octahedral complexes. Octahedral complexes, I have told you about in the last video that octahedral molecule are the molecule in which there are 6 ligands are there, or so we shall take the example that is CO En by 3 tripositive. So now we shall try to write the structure of such a molecule. The structure of this molecule can be written as, that is a CO in a center. There are 6 ethylene diamine molecule. That's why we can write it first En molecule. In short, we can write here what is the formula of ethylene diamine, that is NH2 CH2 CH2 NH2. So we can write here 2 corners indicate the 2 CH2 group. Okay, and these are the linkage of a nitrogen atom to this CH2 group. So we can write in this manner, which I discussed in the last lecture. Now we shall write second En molecule, and here we can write third En molecule like this. Now this structure of molecule, that is COEN by 3 tripositive, rotate the plane polarized light into right hand direction. That's why it is also known as D isomers or dextro isomers. Now if you put the mirror, then it will shows the its image. Now how the image will be formed? If you put this image in front of mirror, then it can be write CO, that is the first molecule of ethylene diamine. Here the second one, and this one is the third one, like this. So it will have the mirror image to each other, and this is a +3 charge. This molecule rotate the ppl to left hand side. That's why we can write here L isomers. Okay, so in this way we can write the example of a such a molecule. Another example we can take, that is PT Cl2 En by 2 dipositive, like this. It is the example which we have to form the mirror image of each other. Now we can draw the structure, that is PT in the center, that is the first En molecule. Here is second En molecule. This one is the first Cl, and this one is the second Cl. The arrow means this donating, this ligand is donating lone pair of electron to the central metal ion. Now we shall close the bracket. There are 2 Cl and 2 En, that's why we can write in this manner. Now put the mirror images of this one, then we can write that is PT, that is the first CL. This will shows the mirror images. This one is the second CL, first EN molecule, and this one is the second EN molecule, like this. Now we shall close the bracket and put the charge, that is positive, in this manner. This molecule shows the mirror images of each other. So in this way, optical isomers or enantiomers are the complex molecular ions which have a non-superimposable mirror images, and they have a tendency to rotate the PPL, that is a plane polarized light, to right hand side. If they rotate PPL to right hand side, that it is also known as dextroisomers or D isomers, and if they rotate the PPL to the left hand side, then it is known as levoisomers or a L isomers. So these are the example of the optical isomers. Now another classification which we have seen, that is the structural isomers. Now we shall discuss here now what is the structural isomers. Another classification we have, it is the most important classification which is being asked in the examination, that is the structural isomers. Now what is structural isomers? Structural isomers possess the different linkages among their constituent atom but have their chemical formula to be the same. Means we can say that the complexes which have the same molecular formula, same chemical or a molecular formula, but they possess different linkage among their atoms or constituent atom, you can say. The structural isomers are classified as, which I have discussed in the last video, that is the first one is a linkage isomers, now we shall discuss one by one. The first, there are four types of structural isomers, or structural isomers are classified into again four classes, that is linkage isomers. Now the second one is the ionization isomers, third one is the coordination isomers, and the fourth one is the solvent isomers. We shall discuss one by one. The first one is the linkage isomers. What is the linkage isomers? Now these isomers are formed when the ligand has two different donor atoms. Means the isomers or complexes having the same molecular formula, but ligand are attached or linked by the two other different atoms. Such type of isomers are termed as linkage isomers. So we can say that, what is the definition? Such isomers, or these isomers, have